In this chapter, we will study about the topological properties of the real line. And then in the next chapter, we will extend these ideas to metric spaces and then to topological spaces. First, we'll talk about the basic idea about an interval. So there are several different types of intervals in the real line. Now, if I take a and b to be two real numbers such that a is less than b, we define the set AB to be the set of all real numbers that are between a and b. So I can write this as a less than x and x less than b. And we call this the open interval. So I can graph this in the real line like this, and usually we can color this. Now it's important to understand that the endpoints a and b does not belong to this set. Similarly, we can define the closed interval, and the notation we use is the closed brackets. So these are the set of all numbers such that a is less than or equal to x and x is less than or equal to b. And I can graph this the same way in the real line. And in this case, the two endpoints a and b belongs to the set. So we have an open interval, and then this is the closed interval. And then we have other types of intervals, and we can define an left open and a right closed interval. So this is x in R is strictly less than x, and this x is less than or equal to b. So in this case, the left endpoint is open and the right endpoint is closed. And similarly, we can define a left closed and a right open interval. So I'm going to just graph this interval. So in this case, the left hand side is closed, and the right hand side we have an open interval. And sometimes these are called half open and half closed intervals. Now, if I take all these intervals are bounded. Now, what do you mean by bounded? That means if I take an interval, say b, I can always find real numbers, so I can bound this interval inside these two real numbers. So these are called bounded intervals. And so we need to have unbounded intervals. So unbounded intervals means one side of the interval will extend indefinitely in the positive or negative directions. These will extend indefinitely either the positive or negative directions. some examples you can think about: the unbounded interval a to infinity. In this case, I can write it using the set notation. All the x that belong to real numbers such that the x is greater than x. So I don't have a bound on the right hand side, so your x will extend up to infinity. And also we can define negative a to b. So in this case, x in R, so your b is greater than x, or x is less than b. And then we can define the similar closed unbounded intervals. And also we can define negative infinity to positive infinity. And exactly this is the set of all real numbers. So if I want to give an example, say, so the interval to infinity, so you have, it goes up to infinity. And as a note, we can define what happens to the closed interval. I start at the point A and end at the point A. Now, is this a finite interval or is this an infinite interval? So usually we define this interval to be a singleton set that only contains the number A. And sometimes we define the empty interval as the empty set.